So what I'm going to do in this video is I'm going to look at the questions I set you for the intersection of lines, and I'm going to work them through and show you the solutions for them. Now, a quick refresher for you. These are the questions that I set. So first one was looking at the point of intersection of a pair of lines. So I gave you two different pairs and I wanted you to see where they intersected. And then what I've asked you in the second question is I've given you three lines and I want to know what point they intersect at, and I also want to know the name which is used to describe three or more lines which do this and intersect at the same point. So let's have a crack at these. So find the points of intersection of the pairs of lines with the equations there and there. So let's do the first one. So I've got 8x minus y equals 21, and I've got 2x plus 3y equals 2. Now remember, when we did intersection of lines, there were a few different techniques. So there was substitution, there was elimination, there was equating. What I'm going to do is I've set this up almost like a pair of simultaneous equations. So I'm going to solve them like this. Now I could choose to get rid of the y variable or the x. If I chose to get rid of the y first, what I would do is take the y's and equate the coefficients, so I'd maybe multiply the top by 3. If I chose to get rid of the x's first, I would take the bottom equation and multiply it by 4, so I had the same coefficient in front of the x's. Either way, it wouldn't matter which one I chose, as long as I solved for both x and then y, or y and then x. So what I'm going to do is I'm going to take the top equation and multiply it by 3. I'm going to get rid of the y's first. So that would give me 3/8, 24x, take away 3y, equals 63. The second equation doesn't change, so that stays as 2x plus 3y equals 2. Now if you look at the y coefficients, they're opposite signs, so if I treat them like a chimney sum and add them, they'll vanish. 24x plus 2x gives me 26x, negative 3y plus 3y gives me nothing, 63 plus 2 gives me 65. So 26x is 65, x is 65 divided by 26, which is 2.5. So my x value for my coordinate is 2.5 or 2.5, whichever is easiest to work with. To get the y, I then take the x and substitute it back into one of these equations to solve for y. Now I'm going to choose this one just because it'll be slightly easier. I end up getting 2 times 2.5 plus 3y equals 2. So that simplifies out to 3y plus 5 equals 2. 3y is equal to 2 minus 5, which is negative 3. So from that, I could say y is equal to negative 1. And I've got my coordinate. At this point, I can then say, fine, so my point of intersection for the two lines is 2.5, comma, negative 1. That's where my two lines meet. Job done. Great. Second question, same sort of logic. 3y minus x equals negative 6. So 3y minus x equals negative 6. Second equation is 3y plus 4x equals negative 1. Now, the coefficients of y are the same already, so it makes sense just to eliminate that first. And because they're the same sign as well, I'm going to subtract. Treat it like a chimney sum and subtract. So 3y take away 3y is nothing. Negative x take away 4x gives me negative 5x. And then negative 6 take away negative 1 is the same as negative 6 plus 1, which gives me negative 5. So negative 5x is negative 5, x is equal to 1. And again, take this and substitute it back into either of these two equations and you'll get the y coordinate. I'm going to go for the top one again. In this case, I'm going to have 3y minus 1 is equal to negative 6. Shove the minus 1 across there, and I get 3y equals negative 5, y equals negative 5/3. So then I can say, fine, so my point where they meet is 1, comma, negative 5 over 3. So I've got my solution for that there. Solving them like this, fairly straightforward. Let's look at this one. So what point do these three lines intersect at, and then what is the name used to describe three or more lines which do this? Well, what we can do to find the point where the three lines intersect is find a point for two of them and then check it works for the third. If it works for the third, then all three of them intersect at that point, and it actually works for all three of them. Doesn't matter which pair we choose. Again, you might want to make it as easy as you possibly can for yourself. So what I'm going to do is I'm going to solve for these two ones here, and then I'm going to substitute in for x and y here. If I substitute x and y in here, I'll end up with a 0. Or I will at least if the point works. So we start by saying 2x minus 5y minus 3 equals 0, and x plus 6y minus 10 equals 0 as well. Now if I take the second one and I multiply it by 2, I get the same x coefficient, so I can then work from there. So let's do that. Top equation stays the same, 2x minus 5y minus 3 equals 0. Bottom equation becomes 2x plus 12y minus 20 equals 0. So I've got them like that. I can treat it as a chimney sum. Both got the same sign. Same sign, we subtract it to get rid of them. 2x take away 2x is nothing. Negative 5y take away 12y gives me negative 16y. And negative 3 take away negative 20 is the same as negative 3 plus 20, which gives me plus 17 equals 0. Solve an equation like this, you get negative 17y equals negative 17, so y is equal to 1. Take your y equal to 1 and put it into one of these two equations to get your x. Now I know we said to substitute in here, but this is when we have both the x and the y we put in here. The two that we were working with, this is where we put the y to find the x. So let's look at the second equation there. I get x plus 6 minus 10 equals 0. So that's x take away 4 is 0. X has to equal 4. So using these 2 points here, I've got that the coordinate of intersection is 4, 1. Now this is where the third line comes into play here, so this line here. What I can do is if I substitute 4 in there for x and 1 in for y, if I do this equation on this side and end up with 0, it works for all 3 of the lines and they all intersect at that point. So let's try it. So I take 3 times 4 plus 2 times 1 minus 14. We hope that that equals 0. 3 times 4 is 12, plus 2 times 1 is 2, take away 14. 12 plus 2 is 14, so it's 14 minus 14. That equals 0. So it works. So all 3 of the lines intersect at that point, 4, 1. That right there works for the 3 of them. Now there's a special name used for any line, any set of 3 or more lines that intersect at the same point like this. These are what are called concurrent lines. Concurrent lines are 3 or more lines which intersect at a single point. Okay, and this is how we go about it. Find it for 2 and check the third. If I'd done this and it hadn't been 14 minus 14 equals 0, it wouldn't have been the right point of intersection, so those 3 lines would not be concurrent, i.e. they would not all intersect at a single point.